Our solar system's largest planet is a world of swirling storms, massive moons, and powerful forces we're only beginning to understand. At more than 300 times the mass of Earth, Jupiter resembles a miniature solar system. Jupiter has 95 recognized moons, including 4 massive ones known as the Galilean moons, one of which, Ganymede, is bigger than Mercury and Pluto. Since reaching Jupiter in 2016, NASA's Juno spacecraft has shown us breathtaking images of this gaseous giant and its moons Ganymede and Europa, and provided groundbreaking insights into Jupiter's atmospheric dynamics and magnetosphere. It's been 2 years since I last released an update on Juno, and since then, the space probe has had several close flybys with the volcanic moon Io, and captured incredible new images of Jupiter's north polar cyclones. Join me as we map out some of Juno's most intriguing new finds, and take a look at the remarkable new images from the Jovian system. To quickly recap, the Juno spacecraft launched from Kennedy Space Center in Cape Canaveral, Florida in 2011. After a monumental 5-year journey spanning 2.8 billion kilometers, Juno entered an orbit around Jupiter in 2016. Its primary mission consisted of 35 polar orbits around the gas giant and ended in 2021, when the space probe was then assigned an extended mission from NASA. This extension added a staggering 42 more orbits, called periyoves, to be completed by 2025, for a grand total of 77 in all. A periyove is the point of a spacecraft's orbit when it is closest to Jupiter, and an apogee is just the opposite. It's the point in an orbit when the spacecraft is farthest away from Jupiter in one of Juno's elliptical orbits. There will be both a perigove and an apogee. Since my last update, Juno conducted its milestone 50th and 60th orbits, and by the end of 2024 it will have completed 69 of its total perigoves, with just 8 remaining before the end of the mission. From breathtaking images to groundbreaking science, let's explore some highlights from Juno's amazing journey over the past 2 years. Our first stop is Io, Jupiter's 3rd largest moon and the most volcanically active world in the solar system. In 2023 and 2024, Juno bravely made several close flybys of Io, coming within about 500 kilometers of the surface of this hellish Jovian moon. During these encounters, Juno snapped its first ever images of Io's northern latitudes, mapped Io's surface, and captured photos of ghostly plumes rising above the horizon. Io is dotted with hundreds of volcanoes across its surface, massive fountains of molten lava, some towering dozens of kilometers into the sky, paint a violent portrait of Io's volcanic prowess. The moon's relentless volcanic fury is driven by tidal heating, as immense gravitational forces stretch and squeeze Io. An easy way to conceptualize tidal heating is to think of Io like the rope in a game of tug-of-war, caught between the pull of Jupiter's powerful gravity and the pull of neighboring moons Europa and Ganymede that orbit farther away from Jupiter. As Io orbits the giant planet and experiences the tug and pull from other nearby moons, it stretches and flexes, generating friction and immense heat in the moon's interior. This heat is what sparks the volcanic activity across Io's surface. Juno's microwave radiometer instrument pierced through the atmosphere, gathering critical data to craft detailed maps of Io's landscape, revealing that it has a relatively smooth surface compared to Jupiter's other Galilean moons. It's theorized that this smooth surface is the result of a constantly renewing surface. Tremendous heat and pressure within Io keeps much of its subsurface in liquid form, and that magma is constantly escaping to the surface to relieve the pressure, whether by filling in craters or bursting through cracks. These frequent lava flows could erase impact craters and cover floodplains with smooth lakes of lava and glassy obsidian-like rock that reflects sunlight. One striking image from Juno's 60th flyby on April 9th, 2024 captured Io's south polar region. While this image was taken from 500 kilometers away from the surface, you can still pick out several dark spots across the moon, many of which are lava-filled calderas and volcanic depressions. Several of Io's volcanic eruptions were also captured by JunoCam, the mission's visible light camera. On October 15th, 2023, JunoCam spotted a plume over the Prometheus volcano just below the terminator line. The Prometheus volcano is one of the most prominent volcanic features on Io, having been seen repeatedly in images of the region taken by Voyager, Galileo, and the Hubble Space Telescope, and now by Juno as well. Voyager 1 was the first to observe Prometheus in 1979, a volcano made up of an enormous caldera and lava flow, with a tall plume of 50 to 100 kilometers that rises above the end of the lava flow. On February 3rd, 2024, Juno caught another 2 plumes in one photo from just 800 kilometers above the surface. These might have been 2 plumes from one gigantic volcano, or 2 volcanoes close to each other. JunoCam also gave us a better look at 2 landmark features on the Jovian moon. One of these was Io's largest volcanic depression, Loki Patera. This 200-kilometer wide area has a lake filled with cooling magma just reaching the surface, rimmed with hot lava, and dotted with unnamed islands. The flyover imaging of Loki Patera provided spectacular reflections of the lake, suggesting that it, along with other areas on Io, is smooth as glass. A simple click on the like button and the subscribe icon helps us bring more cosmic wonders to you. In addition to visible images, the spacecraft used its Jovian Infrared Auroral Mapper, or GIRAM, to study heat sources on Io, an instrument that was originally designed by the Italian Space Agency to monitor auroras on Jupiter. This instrument was able to pinpoint significant heat sources across the moon and provide measurements of thermal emissions radiated in infrared wavelengths. Because of this, NASA scientists with the Juno mission were able to identify another lava lake on Io. This one is called Chores Patera. Visible and infrared images were combined from 2 of Juno's flybys, one in 2022 and the other in 2023, to create a map of Io's volcanic activity. Here, data from the space probe's infrared mapper was overlaid onto JunoCam images of Io, which you see as spots of red, yellow, and bright white color. The data on the left was collected from 80,000 kilometers, and the data on the right was captured at 58,000 kilometers. To put that into perspective, the infrared data in these images has a spatial resolution of about 20 kilometers per pixel and 15 kilometers per pixel, respectively. Meaning, these hotspots represent absolutely massive areas of volcanic activity. And for the first time ever, 30 years worth of data was combined to create a map of volcanic activity on Io. This map shows the varying power output of hotspots where magma has erupted out from the moon's interior. Notably, the map shows the presence of polar volcanoes, while it does not confirm the presence of a magma ocean beneath Io's crust. This information certainly does support that possibility. During the flyby on October 15th, 2023 Juno also captured the first of its kind. Close-up images of Io's northern polar region, taken from 11,700 kilometers above the surface. Because NASA's Voyager and Galileo missions did not gather complete images of this area, Io discovered 3 never-before-seen mountains in the northern latitudes. Those mountains are circled in red in the upper part of this image from Juno Cam, near the line dividing day and night, known as the Terminator. These close flybys also gave us a look at another stunning feature on Io: Steeple Mountain. A striking peak shaped like a cathedral spire. Steeple Mountain is a unique landform that rises between 5 and 7 kilometers above Io's surface. Can you imagine what it might be like to watch the sun rise behind this jagged summit? Or the views, if you could climb to the top. Next, Juno takes us up close and personal to Jupiter's turbulent atmosphere, peering into its swirling storms and mesmerizing stripes. As the largest planet in our solar system, Jupiter is a colossal titan, stretching nearly 70,000 kilometers across and 11 times wider than Earth. It could fit 1,000 of our Earths inside. In fact, some individual storms on the surface of Jupiter are so big, they would swallow up our entire home planet. As part of its extended mission, Juno ventures ever closer to Jupiter's North Pole with each passing orbit, allowing its MWR instrument to capture a series of images from different orientations. This combination of images allows for improved resolution and analysis of the polar storms at different wavelengths. And this data has already revealed that not all polar cyclones are created equal. For example, this series of images depicts Jupiter's northern polar cyclones in 3 different wavelengths. From the left, these images show microwave, visible, and infrared light. The infrared image on the far right, which tells us about heat in the atmosphere, and the composite visible light image at center. Both depict Jupiter's northern polar storms as well-defined and of similar size. However, the microwave image on the far left tells a different story. Take a look at this storm. For example, it shows a notably reduced emissions intensity compared to other storms, despite appearing distinct in the other 2 wavelengths of light. The MWR instrument records the glow of Jupiter's atmosphere in microwave light, with 6 different radio channels that each peer deeper and deeper below the cloud tops. The highest frequency sees the top of the cloud cover, while the lowest can see up to 320 kilometers below. This microwave imaging enables Juno to pierce deep into Jupiter's atmosphere, beneath what we can see with the naked eye. Take another look at the polar cyclones in the microwave light. These 2 storms at the 4 and 6 o'clock positions were about the same size as other nearby cyclones in visible light, but they show more intense microwave signatures than the other storms, which indicates that these extend at least 100 kilometers beneath the tops of the clouds that we see. Also, intriguing is that the central cyclone is clear in both the visible and infrared images. But in the microwave light, this cyclone all but disappears. This indicates that the central cyclone's subsurface structure may be very different from the surrounding storms. With the data from each subsequent flyby of Jupiter's northern polar cyclones, scientists from NASA's MWR team hope to eventually create a detailed 3D map of these polar storms. Not only have we gained invaluable data, but these more recent flybys of Jupiter have provided us with more astonishing images of the giant gaseous planet. On its 61st to 66th flybys, in my opinion, Juno captured some of the most spectacular images of Jupiter's folded, filamentary region in the northern hemisphere, offering a detailed view of the chaotic clouds and cyclonic storms. In this region, the same zonal jets that are known for creating Jupiter's famous banded cloud patterns. Breakdown. And without these jets, the planet's clouds swirl into turbulent patterns that rapidly evolve over the course of just a few days, like a choreographed dance that's always changing and never ends. This unforgettable swirling canvas of blues, whites, and browns is something I could stare at for hours, and for planetary scientists. These beautiful and sometimes terrifying images hold clues about Jupiter's weather patterns and atmospheric dynamics. If this journey amazed you as much as it did us, show your support with a like and a subscribe. On March 7th, 2024, Juno's 59th period gave us a rather special set of images of Jupiter. Here we see the planet's famous atmospheric belts and swirling storms, including the Great Red Spot. But if you look a little closer, a charming detail is revealed. Jupiter's tiny moon, Amalthea, is visible in these two images. At just 84 kilometers wide, Amalthea is shaped like a potato, as it lacks the mass to pull itself into a sphere. This tiny moon circles Jupiter inside Io's orbit, and takes roughly half of one Earth day to complete an orbit. Curiously, Amalthea holds the title of the reddest object in our solar system, its crimson surface radiating more heat than it absorbs from the distant sun. Perhaps this is caused by electric currents that are induced within the moon as it orbits within Jupiter's magnetic field. Or maybe it's caused by tidal heating from Jupiter's gravity. And of course, Juno also captured some lovely images of Jupiter's classic bands on its recent orbits, including this one from the 54th period on September 7th, 2023, and this one, taken during the 62nd orbit on June 13th, 2024. Another objective of the Juno mission is to quantify the amount of oxygen and hydrogen molecules, which make up water, that are present in Jupiter's atmosphere. To help us understand more about the planet's water abundance, Jupiter was likely the first planet in our solar system to form, and it contains the majority of gas and dust that didn't become part of the sun, which means it is also a critical piece of the puzzle of our solar system's formation. Additionally, the planet's water abundance has implications for its meteorology, like how wind currents flow and what the planet's internal structure is like. Luckily, Juno is helping us to answer these important questions. Recent MWR data has helped to gauge Jupiter's water abundance, showing roughly 3 to 4 times the elemental abundance of hydrogen at the equator, as compared to the average concentration of that element found in the Sun. This supports the idea that water ice material may have been the source of heavy element enrichment during our solar system's formation. If this is the case, it would mean that as Jupiter formed, it accumulated not only hydrogen and helium, but also heavier elements contained in water ice material, which was abundant in the early solar system. However, recent measurements from Juno show a surprisingly low water abundance in Jupiter's core, raising new questions as scientists expected to see more water in the core, if water ice were indeed the primary source of Jupiter's heavier elements. So for now, the formation of Jupiter remains a mystery that scientists are still trying to sort out. The final year, the end of Juno's extended mission, is drawing near. Only 8 more periods are planned for 2025, with its flybys of Ganymede, Europa, and Io now completed. The final year of Juno's life will be spent focusing on Jupiter itself, gathering more data on the gas giant and making the closest flybys yet. And with each new set of data and every new image, we have an opportunity to put together even more pieces of this giant gas puzzle. On September 17th, 2025, Juno will bid a dramatic farewell with its 77th and final close encounter with Jupiter before being decommissioned. And like a final firework to mark the end of its phenomenal mission, NASA will deorbit the probe by burning it up in Jupiter's atmosphere to avoid any risk of contaminating the planet's moon. What a breathtaking conclusion to a monumental mission. Yet even now, Juno remains a bold space explorer, continuing to reveal the awe-inspiring beauty and fierce power of our solar system's largest neighbor. Juno's journey has delivered not only groundbreaking scientific insights, but also stunning visuals of a distant and mysterious world. From the violent cyclones swirling over Jupiter's north pole to the towering, volcanic plumes erupting from its moon, Io, Juno has deepened our understanding of this gas giant's vibrant and complex nature, a planet that never ceases to amaze us. We sincerely thank you for watching and joining us on this extraordinary voyage of discovery. If you found this content inspiring and want to continue exploring the cosmos with us, don't forget to like, subscribe to the channel, and turn on the notification bell so you won't miss our next incredible adventures. Until then, goodbye, and see you on the next awe-filled journey through the stars.